guys, welcome to video 3. So today is the day we're going to start really getting into some chemistry. So we're going to talk about the basics of elements and compounds. But before that, you really need to know how to read the periodic table because that is just a vital skill for all of chemistry. So when you're reading the periodic table, you're going to see atomic symbols like this. So this is hydrogen, its symbol is H, and you're going to have things in each one of the corners of it. So here in the bottom left corner, you're going to have a 1, and that is the atomic number, which symbolizes the number of protons. And a hydrogen atom is going to have 1 proton. That doesn't change. That is a unique number for every single element. And so up here, you're going to have the mass number, and that's the number of protons plus the number of neutrons. And in this particular hydrogen isotope, this is your regular hydrogen. That's going to be the most common isotope. And that's going to have only 1 proton and 0 neutrons. So 1 plus 0 is still going to be 1 up here. And I mentioned an isotope. So what an isotope is it is a different version of the element that has the same number of protons but a different number of neutrons. So hydrogen is going to have 3 isotopes. You have the most common one, which is this one right here, which only has 1 proton and no neutrons. There's also a version of hydrogen that has 1 proton and 1 neutron. That would have a 2 up here in the mass number. And there's also an isotope of hydrogen that has 1 proton and 2 neutrons, and that's going to have a 3 up here. So moving on to the right side, here in the bottom right corner, you're going to find information about the number of atoms in that you have. So here we only have 1 hydrogen atom, so we just don't write anything there. If there's nothing written there, you assume that there's just 1. If we did have 2, there would be a little 2 subscript here, and 3 and 4, or however many you have. And up here, you're going to have the charge of the atom. A neutral hydrogen atom is going to have a charge of 0, so we just don't write anything up here in the charge. But if it were an ion, so like for example, if it was an H plus ion, there would be a plus here. Or if it was a minus, there would be a minus, or 2 plus, 2 minus. The number and the direction of the charge would be indicated here. The next concept we're going to be discussing is atomic mass. So the atomic mass is different from the mass number. That is something really important to note. The mass number is which you're going to find in the top left corner of an atom. That is going to be unique to each isotope, but the atomic mass is for the entire element. It's the weighted average of the masses of all the isotopes. And what I mean by weighted average is that all of the isotopes have different natural abundances. Like I mentioned that most of natural hydrogen is just going to have 1 proton and no neutrons. And the versions with more neutrons are much, much rarer. So they're going to have much less weighting. So the way that you find the atomic mass is you multiply each isotope's mass number by its frequency that is found in nature, which is going to be constant no matter where you look for it, and you add all these together, and that's how you get to the atomic mass. So like I mentioned, it's the weighted average of isotope masses, but it can also be interpreted another way as the number of grams of a particular element that are in a mole. So what is a mole? A mole is a super important concept in chemistry. Basically, 1 mole, which is abbreviated MOL, is equal to 6.022 times 10 to the 23rd atoms or particles or molecules or whatever you're counting at the atomic scale. And this number right here is called Avogadro's number, and it's a really important number for doing conversions from grams or moles to a number of atoms. So what do I mean by this? Here's an example. So hydrogen, its atomic mass is going to be approximately 1 gram per mole. So that means I have 1 gram in a mole. And what is a mole? A mole is 6.022 times 10 to the 23rd atoms. So that is basically telling me that if I have a gram of hydrogen, I have this many atoms of hydrogen. Okay, so now that we've talked a lot about elements, let's go into a discussion of compounds. So when you're talking about compounds, there's going to be 3 major types of bonds that make up a compound. You're going to have ionic compounds, covalent, and metallic. So let's first talk about covalent compounds. So a covalent compound is called a molecule. So like an example would be carbon dioxide. That is a molecule because it's covalently bonded. And so there's some atoms which naturally form covalent bonds, and those are going to be H2, N2, O2, F2, Cl2, Br2, and I. So these atoms are rarely ever found by themselves. They are always with another one of their same kind of element. So you're not gonna find a natural free hydrogen. You're gonna find it in the H2 molecule. And these are molecules because they are covalently binded, even though they only have one type of element in them. So these, if you want a way to remember the diatomics, they actually form the number 7 on the periodic table, and there are 7 of them, so that is really nice. And we also have sulfur, which forms S8, and phosphorus, which forms P4, and these are just special covalent compounds. And how do we name covalent compounds? So these are used with Greek number prefixes. So we're going to have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, and so on. You can always look up a long list of all of the Greek naming prefixes, but here's the first 5, which you're going to be using really commonly. But some of them do actually have common names, like water. We don't call it dihydrogen monoxide, we just call it water. And same thing with methane. So yeah, these Greek number prefixes are used in how we name carbon dioxide, because you can see in carbon dioxide there's 1 carbon, so that's just carbon. And oxygen there's 2 of them, so we're going to use the prefix for 2, that's di, so dioxide. So we don't really need to go that in depth into metallic bonding right now, so let's talk about ionic bonds. So ionic compounds are not molecules. That's an important thing to remember. So one unit of an ionic compound is called a formula unit. It's not a molecule because they're not separate molecules. It forms one large crystal structure. So a ionic compound consists of a cation, which is a positively charged ion, plus an anion, which is a negatively charged ion, and they are basically attracting each other because of their opposite charges. So I never really formally defined an ion. An ion is basically a charged version of an element. So an atom that has either lost or gained electrons in order to get greater stability. So when you have an ionic compound, it can either be a metal plus a nonmetal, because metals usually form positive ions and nonmetals usually form negative ions, or it could be a metal plus a polyatomic ion. So a polyatomic ion is going to be a group of covalently bonded atoms that actually behaves like a single ion. So after this, I'm going to show you a chart of common polyatomic ions and their names and charges, and those are just something you have to memorize, just common polyatomics, because they're really useful in terms of naming and identifying compounds. So like I said, here's the chart of polyatomic ions, and the important thing to remember about these is that the charge that you see up in the top right-hand corner applies to the entire group of atoms, not just to the last atom. So you do have to look at it like one single ion. So for example, the ammonium ion in the very top left corner, that would be able to theoretically combine with any negatively charged ion like Cl- or Br- and be able to form a normal ionic compound. So you don't consider it as one nitrogen and 4 hydrogens, you consider it as one positively charged ammonium ion. So now let's talk about how we name ionic compounds. So essentially the formula for naming an ionic compound is the cation plus the root of the anion plus ide. So for example, NaCl is called sodium chloride. So the cation is going to be a sodium ion, so sodium, and then the root of the chlorine is going to be chlor plus ide, so sodium chloride, right? And another concept that we have to know with ionic compounds is that some of them are electrolytes. So what this basically means is when you dissolve them in water, they dissociate into their individual ions. Like for example, if you, sodium chloride, which is regular table salt, if you dissolve it in water, it's no longer going to be solid sodium chloride. It dissociates into its 2 ions, Na plus and Cl minus. And this solution, since it has some ions in it, is able to actually conduct electricity. And that's why it's called an electrolyte. But not all ionic compounds are going to dissociate in water. Okay, that's it for today. Thank you guys for watching, and I hope to see you next time.